Welcome to Team 35's Intel-IXN GOSH Holo Window project. My name is Joel.
And my name is Sibga. We are working with Intel and GOSH Drive. Intel technology is already being used in healthcare. This is helping to improve the quality and cost of healthcare around the world.
Normal 2D imaging for CT scans is normally very limiting, and as such usually takes place away from the patient bedside. And as such, it can be hard to brief the patient and other clinicians on the current situation.
The Holo Window will attempt to bridge that gap by rendering a 3D model of the patient's CT scans in front of them to give a more tangible idea to how a patient's organs work and are affected, and how exactly the treatment or surgery will proceed.
Our project will make use of Intel NUCs, which are small computers that complete high-cost processing tasks.
We have formulated our requirements using the Moscow method to help us prioritize the requirements of the project. We have also divided our requirements according to the intended users, who will be both medical professionals and patients.
Overall, the system should be simple and intuitive to use and control. The system should also be clear with minimal distraction from the subject. However, medical professionals may be able to see a more detailed view with more data.
The core features of the project are to be able to dynamically load CT scans and holograms and project them onto a screen using pico projectors, to display a UI, to allow the selection of different holograms, and to integrate pre-existing patient data into the UI.
It is imperative that the project works directly with the Holo repository project, which can provide us with patient holograms and data from an endpoint and is secured with FHIR.
From our research, we learnt that one of the main issues doctors faced was being able to communicate with their patients and their family members effectively. This is due to a knowledge gap. The aim of our project is to bridge this gap between medical professionals and their patients to provide a high-level visual explanation of patient issues.
Our proposed system architecture involves using Unity and the existing Holo repository. We send a web request to the Holo repository endpoint via scripting and pass the response stream data using the newtonsoft.json library, or save any binary data we receive for later use. The Holo repository uses the OpenVinyl toolkit and converts the DICOM scans to GLTF form. The scans are dynamically loaded into a Unity scene using the GLTF utility package, and we attach pre-made scripts that can be used to manipulate the scans. On completion, the rest of the UI is set up and populated. Using Unity's multi-monitor display feature, the single scene will be divided into 4 sections. These will be displayed via a pico projector onto the Holo window.
This is the intended architecture for the window. Each pico projector will be attached to a corner. The Intel NUC will also be attached to the Holo window. The actual window will be a 1 by 1.5 meter acrylic screen, inclined at a 45-degree angle. This is designed to be wheeled in front of a patient, as well as around the hospital.
We used a range of technologies to aid with development. Some of these include
the Intel NUCs will be used as a computing unit to query the Holo repository and dynamically load the scans onto the Holo window. The NUC will provide graphics acceleration and will also provide local processing capability, allowing us to implement features that may require stronger processing power. Additionally, the NUC has 4 outputs. These will be used to connect the 4 pico projectors.
we are using a combination of web requests, GLTF utility, and Newtonsoft's JSON parser to be able to load the scans and patient data at runtime.
We are also using Unity to develop the interface to be shown on the screen. Scans will first be loaded into a Unity scene into the required form. Unity can support multi-monitor display. This can be used with a NUC to divide the scene into separate Unity textures and display each texture through a pico projector. We also used Clara.io, which is an open source platform for obtaining 3D models, which we use to demonstrate functionality.
We will now demonstrate the key features we have implemented. As of this video, we have successfully implemented the core deliverables. As such, we can load CT scans from the Holo repository at runtime, populate the UI with selectable holograms, and display patient data on the screen for viewing.
This is the demo using the Clara.io scans. These are open source 3D models that we found online. As you can see, you can rotate these scans in the X, Y, and Z directions. You can also choose other scans from the UI and do the same. You can also move the camera view to view the scans from another angle. And you can reset the camera once you're done. The patient view is also expandable. Possible future developments include being able to control the UI using gesture controls, integrating live patient data with hospital measuring equipment, integrating the holo window with over-body tracking, and allowing doctor notes to be added to the hologram. We have successfully completed all of our core requirements. Our must-have requirements are being able to load DICOM data from the Holo repository and display them onto a screen, display the UI on the lower half of the screen, and allow the selection of different holograms. Our should-have requirement is to integrate pre-existing patient data with the UI, which we have done by loading FHIR data into our patient data scroller. Our could-have requirements are incomplete and are hopefully development goals for future developers.
We hope you enjoyed learning about our project. Thank you.